My name's Bob Ballantyne. I'm distinguished, a distinguished member of tech staff at Dell Technologies. I work in the ISG division. I've been there 15 years or so. I've been in DevOps for 10 plus years, working with Kubernetes for maybe 6 years. So, fair bit. The talk today is about some of the stuff that we're currently doing to take the ISG enterprise to the next level. It's all about serving the developers, but the interesting thing from the perspective of this conference is we're really using Kubernetes as the basis for all of this. And to do that has certain challenges, as we'll get into some of them. But we chose it because of the reliability, scalability, and those sort of things. Jumping in, these are the sort of items that we're going to be covering today. It's going to be a packed talk, not too technical because there's just too much for it, but let's get going. So first thing is slightly controversial statement to begin with, just to get you fired up. Traditional CI/CD pipelines are not suitable for native Kubernetes. What we mean by that is tools like Kubernetes. I control horrible as far as Kubernetes is concerned because it's using resources, it's sitting there all the time. Most of the time, it's not doing much. So you've got to get rid of your Kubernetes controllers. Doing that, how do you control your pipelines? Other things like GitHub Actions, they don't work quite as well. You've got GitHub pods, which do work well, but the combination is not plug and play. Travis CI, Circle CI, you do a lot yourself. They're good for developers, but it doesn't allow you to really provide that workhorse. What we've got though is on Kubernetes, great thing, namespaces. We all know about namespaces, but within the enterprise, they make a huge difference because we can have namespaces for our dev environments, for our staging environments, for our production environments. This is what we want. We want to keep all these environments separate. As you'll see, we've got other uses for them. And then within these, we've got the different orchestration engines that we can run. That's a problem because within the enterprise, we're coming from an environment that was predominantly open source Jenkins. There's hundreds and hundreds of Jenkins pipelines defined. If we want to be using Kubernetes efficiently, and we don't want to use Jenkins open source, what do? Well, we had to come up with this notion of a pipeline abstraction, and I'll get into that in just a second. But basically, the pipeline abstraction allows developers to describe what they want to do using our DSL. That's just a YAML file, and then we'll take that and translate it into whichever orchestration engine we want to use. That way we get out of the business of being tied to one tool. We also get out of the business of having problems when we want to try a different tool and all these sort of things. Enough about that. As I said, this talk is more about pipelines and how we deal with them in Kubernetes. The big question is, what defines a pipeline? So to us, a pipeline is everything. If it's automation, then it's a pipeline. Pipelines connect one thing to another, whether it's a developer to the main branch to production, or developer to production, out to customers, integration with third parties, DevOps to Kubernetes, DevOps to orchestration. Whenever anything has got to be deployed, it doesn't matter where, it's got to be a pipeline. Did I say if it's not a pipeline, then it's manual? That means it's broken. We've got to be using pipelines everywhere. I used to work in a refinery, and that was pipelines everywhere, and I used to be thinking, what is this? I now understand, because pipelines are everywhere. And the way that we use them is, as you see on the screen, we use them to scale. because everything we do gets wrapped in a GitHub pull request. That means, one second, that means that the GitHub branches represent our state. In between those branches, we have pull requests, and that effectively gives us a cookie cutter mechanism. You see over there, it forms a ladder. And the only difference between these cookie cutter representations is the types of tests we're doing, or the types of functionality that's there. And so we can actually build up a framework there to fit within that pull request. The pull request then is a nice, easy place for developers to go, not even developers, for anyone. Anyone that's got to authorize something or review something, make sure that everything's okay for the next step in the pipeline. Perfect. And we also have the same with Artifactory. We're tying the two of those two together because these days Artifactory from JFrog provides a lot of this stuff as well. So it's another pipeline. We just tie it in the same way, and we have the functionality going together. So much for the generality of pipelines. Within our pipeline, as I said, everything is in the pipeline, absolutely everything, because we want all that automation. It's the only way an enterprise such as ours can scale to the size of 11,000 developers, 60 product units, that sort of thing. So everything has got to be connected, and it needs to be automated. If it's not automated, it's broken. Or the same thing, it's manual, which means it's broken. To do that, we've got a couple of important things besides the Kubernetes and the Kafka that you see down here. We have firehose patterns. That's just a fancy name for how we use webhooks to get data into Kafka. We've got the pipeline abstractions that we talked about before. We use standard GitOps through Argo CD to take the results of GitHub pull requests and synchronize with Kubernetes. So these are the sort of general pieces that we're using to give this cookie cutter type environment. Sorry. And these are the tools that we're doing it with. We standardized on these tools. There were 10 times this number of tools when we started, and we cut it down so that we could understand the problems and start making the connections between the tools. Once we get the standard connections, the standard pipelines established, then we might think about introducing other tools. But for just now, the focus is all around getting the pipelines between all of these tools set up, running, so that nobody has to do anything, or no one has to think about it, I should say. There's still work to be done. Pipelines to pull requests to create, etc. So how do we go about this? As I say, it's a massive project. We've been on it now for a year plus. And the first priority that was given down to us was do no harm. That was the utmost importance, because think about it, Dell is a big company. We have a lot of products, 50 odd, 60 odd, generating a lot of money. How much, I have no idea. I just know it's a lot of money. If our project, which is affecting all the developers, were to crash and burn, that would be terrible for Dell. That we cannot let that happen. That is just out of the question. There's just no way. We have got to keep the boat going forward. We've got to keep that car running as we are making the changes. So do no harm was the number one. Number two, everyone's aware of it today, security. We can't have ransomware attacks coming in and undoing stuff that we're working on. That's just goes without saying. Next, we come to this sort of 4 DevOps type principles that we were going after when we were designing this system. And that was the traceability, reliability, repeatability, scalability. Well, you see some of those come with Kubernetes, and that's why we chose Kubernetes. That was the big thing, just the stability, the scalability, the ease with which you can stand up hot spares, all of that sort of thing. The metrics within Kubernetes. I just love Kubernetes, I'm sorry. We also went with Kafka. And Kafka, like a lot of the other tools that I showed in the previous slide, with the exception of GitHub, can all be stood up in Kubernetes. So now we've got this environment where we can fail one site and move everything over to another site. We don't need to have downtimes. We can keep the developers going. We can keep them running. We've got the data that can migrate with the applications and minimal downtime. We have the data stored with everything so that it just keeps moving forward. And the bulk of our storage is actually in our Kafka topics. That's because we use that for an event-based system, and I'll get into that in the next slide. So the next one was the primary directive from management. You've got to simplify everything for developers. And this is the sort of common mantra that you're hearing around Kubernetes in general these days. It's got to be simple for people to use. If it's not simple, they'll do something else. They'll find another solution. And developers are one of the best at doing that. If you can't make it simple for a developer, they will just figure out how to do something else. Excuse me. So those were the main goals that were set out. And as a consequence of all these, we found that we had to fight a cultural change. Fortunately, we had top management backing us, so we were able to carry these ideas forward. Without that, we would have been having an uphill battle. That cultural change is substantial within the size of a company like Dell, or we're not talking about all of Dell, we're talking about Dell Technologies or ISG, but it is still substantial because developers like to do things their way. But we managed to convince them with this talk about traceability, using sources of truth, using Kafka because of the fact that it allows us to produce the reliable, scalable event-based system where we can show them what's going on. Having the traceability back to the sources of truth, that was something that the developers liked because that allowed them to dig in and find problems when problems arise, not just on the DevOps stuff that we're responsible for, but also on their side when they're making code changes. And for us, it allows us to debug everything in our pipelines. So major aspect there. As we're moving forward, we're getting into using Kubernetes, and this is what you're hearing a lot about today. But we're using it with Kafka, as I said. Kafka is all Dockerized. We can run it in Kubernetes. We use it for its persistent storage. We have near real-time updates. But the biggest thing here is Kafka produces the events, which, let's face it, Kubernetes is based on events as well. We have extended that beyond Kubernetes because of our use of Kafka. Because in the enterprise, we've got all this baggage that we've got to bring into Kubernetes. It's not just going to happen overnight. We've still got a lot of groups. We've still got more than half the groups actually that have got to be brought in. They're not going to come in easily. They're going to want to take their time, and a lot of them haven't even got to Dockerize their builds or Dockerize their tests or things like that. We've got to give them the tools to do that. We've got to get them into a Kubernetes development environment. Some of the teams are actually using Kubernetes, but they're running it from who knows where. So all of this makes it difficult. Kubernetes and Kafka helped solve this because with Kafka, we've got the events, which mirrors everything around us. We've got our object model that describes that. With Kubernetes, We can segment things. We can, somebody's jumping me forward here. As I said earlier, we've got the namespaces. I mentioned the production, the staging, and the dev namespaces. We also have namespaces per BU. So now we can limit blast radiuses when something goes wrong. Supposing someone brought something in the wrong way, rather than through the company mandated way they brought it in on their laptop and something, we can contain that because it's going to Kubernetes and we've limited the blast radiuses there. We've also got all the checks on JFrog, on Artifactory, that further limits it. So the combination is just wonderful. And that's why we've got the silos per product unit. We also set up our configuration in similar fashions, and we've got umpteen layers of configuration per BU, per environment, per application, you name it. And that's another of the important things that we had to learn, was how to deal with that configuration. As I mentioned earlier, at the tail end, when things are going into the main branches or getting deployed on Kubernetes, we're now using Argo CD, and that's because we have a liking for GitOps. We use Argo CD just to synchronize Kubernetes with what we've got in Git. Again, back to this source of truth, we have everything in Git. So as we use our pull requests and our automation and our pipelines to move things through branches in GitHub, it gets to the final branch where we deploy to production. And that's what Argo CD is doing. The last one on the slide there is the pipeline, the abstract pipelines, which I've mentioned, so I won't go into that. So some of the challenges we've got that we've faced, as I said, onboarding 60 plus snowflakes has not been an easy task. We're not even 50% of the way through it yet. But just that variation is a really tremendous task. Getting visibilities into the different processes of the different groups has been eye-opening. This is something that a lot of them didn't have before, and it's been eye-opening for them and for us. We've also been providing some of the common checks that they've been asking for, that they just haven't had a chance to add themselves. But the way we've been adding these is through our pipelines running in Kubernetes. This was how we started. This is what we're using to give all these different organizations a taste of how to do it. As we're doing this as well, we had to architect the whole system to be this event-based system. And we did that using a technique called event storming. The event technique, and I've got to thank one of my leaders, Mark Interanti, for this. He introduced us to event storming, and it has been a godsend because it allows us to draw pictures about how we want things to progress through Kubernetes, how we want our pipelines to be, and where the functionality is, and how we want to break things down into microservices. It's like sliced bread. It's one of the greatest things. So the takeaways here, as I said, we wanted to go with Kubernetes for our scaling. We wanted Kafka because it's an event-based system that has the storage and the scalability. It's got the highly available nature because of the cluster, excuse me, the clusters it has, and the way that it votes between the different brokers or zookeepers. And the events are the messages, same thing in the way that we think, provides a communication mechanism. So throw out all these point-to-point communications. We hate them. They're forever breaking. It increases the reliability of the entire system. The next thing that we did was the wrapping everything in GitHub pull requests. That's what gives us our cookie cutter approach, our quality ladders, or this mechanism where people can review changes and allow them through slowly until they build up confidence. But it's also this pockets of automation in our pipelines. where we do certain jobs. At some point, we're going to get rid of the manual part, or we do get rid of the manual part. Not some. It's just the normal flow for the organizations is they don't trust they don't trust the automation, so they want to put in the manual blocks, and we'll let them until they get their confidence, and then we can take out that manual step, and it just allows the pipeline to flow as though it's water going through a normal pipe. So this gives us the stability and the traceability in GitHub. The pipeline abstraction, as I mentioned before, enables us to transition from this massive amount of Jenkins pipelines that are out there. It's not just Jenkins pipelines, scripted pipelines. We've still got some freestyle jobs and all of that stuff. But this abstraction allows us to describe that in a way that developers can onboard onto that. They can describe what they want to do, and then the DevOps side can choose which parts of the pipeline are implemented in Argo Flow, in GitHub Actions, in Jenkins X, you name it. Initially, we'll stick with one tool, but it gives us the freedom. And then lastly, I think I've said the word over and over, so you must have heard it by now. Pipelines are everywhere. They really are. And that, if anything, is the biggest takeaway from this discussion. And with that, I'd like to thank you all very much for sitting and listening here. It's been a pleasure talking to you. Thank you very much. If you want to contact me, feel free. I'm on LinkedIn. I'm on the Slack channel for the event here at Kubecon. I'm happy to answer any questions, get into more of the technical details of the discussion. And that's it. Thank you.